Okay, Nick here, and I got my famous tennis ball set up as the Earth, and I got my now famous golf ball set up as the Moon. And if you notice, I darkened in the left side of the golf ball, showing the side facing away from the sun, and the other side, the white side, is the face lit up by the sun. Okay, the dark side is basically the night side of the moon. Same thing for the Earth. When we're facing away from the sun, we're in the nighttime or the dark side of the Earth. And the other side, which is lit, is the side lit up by the sun. The only side of the moon that is ever lit up is the side facing the sun. So, in this video, I want to show you both how the sunrise and the lunar phases, the phases of the moon, happen due to our angular perspective from standing on the Earth. So let's start with the sunrise. Now the sun doesn't move at all, but we're going to rotate with the Earth. The Earth is rotating. Not going to touch the sun. Too far away. It's 93 million miles away, right? So as I rotate, looks like the Earth is rising. Looks like the Earth is moving, but it's not. It's just us rotating towards the sun. That's our angular view to the sun. That's what's causing sunrise. Or when the sun appears, it's causing the sun to appear to us. We start at nighttime and we end up turning towards the sun, causing the sunrise. Now, same thing for the moon. Now, the moon orbits the Earth. And it obviously takes 27, 28 days for the moon to orbit the Earth. And as you notice that when I do this, the side lit up by the sun never changes. It's always, I never touch the moon. But yet we can simulate, we can show the phases of the moon. That was a half moon. We can show the phases of the moon by simply changing our angular perspective of the moon. We're seeing more of the dark side of the moon and less of the lit side. That's the quarter moon. So we're going to come around. We're going to come around. And we're going to see the dark side of the moon. Okay, called the void of course moon. Now, if we come around again, now instead of seeing more and more of the dark side, we're going to start seeing more of the lit side. Okay. Okay. More and more of the lit side. That's another quarter moon. Now, if we had a contrast, it would be really easy to see the dark side. But we got no contrast in the space, darkness of space. There's no contrast. So we're going to come around and see the half moon. We're going to come around again and see kind of like a quarter of the dark side of the moon. That's what we're really seeing. You know, the phase of the moon from the Earth, the perspective of the Earth, the angular view from the Earth. Okay. Now we're seeing the full on, what we call a full moon, where all we're seeing is the lit side of the moon and the dark side is not visible at all. Now, if our orbits matched, that's what would be happening. Okay, you can see that. That is the lunar eclipse is actually caused by the shadow of the Earth. but not the phases of the moon. The phases of the moon is our angular perspective between the lit side and the dark side of the moon. Okay, see that? So now we're back to our beginning perspective. Okay, the half moon. And the only side of the moon that is ever lit up is the side facing the sun. We'd never change that, and the dark side is always facing away from the sun. Okay, Nick out.